All right. This is the first class of programming, InventorCAM Basics. 2 weeks ago, we had the second class of the first class series, which was an introduction to InventorCAM. The first part was the settings, and the second was menus and files management. Today, we're going to be focusing on programming, and in 2 weeks, we're going to continue programming. After that, we'll get into some iMachining, but for now, this is where we're starting. This is for InventorCAM. Last week we did the same thing, but it was inside SolidCAM. You can go ahead and type in questions here, or you can raise your hand, but I probably won't see those until we get done with it, so we'll take answers or questions and answers at the very end. I'm going to go ahead and type in my name, or my name and my email address down here, so that if you need to send me an email to ask more questions, or if you just want to simply request this video. I did record this morning's, didn't like the way it came out, so I'm going to do it again today, right now. So if you'd like this recording, just send me an email to darrin.bryant, that's D-A-R-R-I-N .bryant, B-R-Y-A-N-T, at solidcam.com, and I'll send any kind of videos out that you'd like. I actually have an email already formatted that tells you all the videos that I have so far. We are starting a whole new video series on Inventor 2014, so some of the videos that I have are from previous versions, so I just want to update them. So that's actually what we're doing here. So let's go ahead and jump in. I'm not going to talk about starting the CAM project because we've already discussed that in the other two classes that came before this. So I'm just going to get into this, and then we'll get into the actual programming. Again, if you have your questions, you can either raise your hand or type your question into your question right there on the GoToMeeting dashboard. Let's see. We will use that one. Define a coordinate system real quick. I'll put my origin back here, back left. Stock, a lot of ways. We talked about that again 2 weeks ago, but I'm going to actually use 3D model and choose my part and finish, as well as my target, and that'll do. Save and calculate, or save and exit, sorry. All right, so we went through all the menu structures and where your files are and all that stuff last 2 weeks ago, so this is strictly on programming. We're going to start off with a facing routine, because I do have some extra stock here at the top, actually quite a bit. And then we'll get into some pocketing and maybe some profiling, some drilling, that kind of thing. So start off with facing. Facing is it's a simple operation. So if you're looking to avoid air cuts, or if you're looking to go around structures like bosses and stuff, you might think about using pocketing or even possibly profiling. But I'm going to use face mill because I'm just doing a very basic face. So all the coordinate systems that you've created are going to be listed right here in your drop-down box. You can create another one right here, right now, or you could come up here and create one from there. However, I have the one that I need, so I'm going to go ahead and pick some geometry. Now let me come back here real quick. This dialog box here is what all of our dialog boxes look like, all of them. Doesn't matter if you're doing 2, 3, 4, 5 axis, mill turn lathe, wire EDM, probing, doesn't matter. They all look the same. What does change is your workflow area. Okay, inside your workflow area, it's very easy to follow. You simply start at the top, work your way down. Obviously, a 5-axis toolpath is going to have more options here in this workflow area than a 2-axis option, but still, you simply start at the top and work your way down. Most of the stuff you don't even get into. Like, I won't even get into links or motion control or miscellaneous parameters. I'm going to pick geometry, pick tools, pick levels, and a technology. That's pretty much what you're going to do for just about every operation you go into. So starting with geometry, and because I'm in 2D, I'm going to be picking off the wireframe. So I can do this several ways. Right now I'm selected on model, so I can pick my model. I can pick a face, so if I say face and I hit define, I can just simply grab that face and it automatically creates it for me. Okay. You can also do a profile, so if it wasn't exactly square or it wasn't all attached or something, you can simply define. You can click on that, and you could chain around this. Okay, and we're going to come back to this screen because we need to talk about it. In this case, though, what I'll probably end up doing is just hitting stock, because I actually use the 3D model option for my stock, and when you do that, it actually puts in your stock right inside your drop-down menu. However, if you were going to use, let's do profile. So I want to talk about some of the selection methods in here. This screen you're going to see a lot. Anytime you're picking geometry, you're going to see this. Okay. Curve is nothing more than an edge, any edge on here. Okay. Now curve plus closed corners, let's reject that real quick. So if I was to select this, and I didn't want to come around this corner here, instead I wanted to come out sharp, well, I could use curve plus closed corners and select this other edge, and it closes that off for me. Let's reject that. Loop, let's say I select this one and I choose loop. What it does is it highlights the one that it thinks that I want, probably because I'm in Z, but it also says, well, there's another loop here you can select. So I could pick yellow or white, and it'll automatically choose that loop for me. But I'm not going to do that. I'm going to say, let's replace this. All right. Point to point. So if we select curve, I'm going to go ahead and do point to point, and you literally can go to any point you want on here. Now, if you want to pick a vertex on the part, you can right-click to the model by hitting select. Then you can simply pick there. It does not matter at what location you're at in Z. What matters is the way it looks from the Z value. We don't care where it is in Z here, because you're 2D and you're going to be selecting the start point and the end point, so it doesn't matter where you select it. So that's what point to point does. Go to any point you want and keep going to different points if you'd like. It doesn't really matter. Select point. There we go. Go anywhere you like. Let's reject that chain. And let's do arc by 3 points. Let's replace this. And we're going to select the curve. Arc by 3 points simply uses the last element, the last point in the element that you just selected, and the next 2 points to create your arc. So if I do arc by 3 points, it's going to use this one. And let's say if I use this one and this one, you'll see it generates an arc through those 3 points. I don't know where that's useful, but we have that selection in there. So let's reject that. Now, auto select. This is very handy. I generally use the auto constant Z quite often. So if I right click and let's do a replace again, I'm going to select an edge. And if I use auto constant Z, it means that it's going to stay in that Z. Wherever this element is selected, whether it's low or high, it doesn't matter. It's going to find the chain in that particular Z. So if I select it, it just grabs that whole loop. Now it's kind of like loop, except the loop says, well, you can do a chain here or you can do a chain down here. But this one just automatically does it in Z. So it's one that I use a lot. Auto general is kind of similar, but you can go up and down. Let's replace this, and we'll say there, and we'll hit auto general. Notice how it highlights the next 2 elements. Either one I can pick. So if I pick this one, it'll highlight the next 2. I can pick that one. It'll highlight, this one and that one, so on and so forth, all the way around. Let's reject that. Now, if you want to chain to a particular area, you can simply do this. Let's replace it. We're going to chain from here, and let's say I want to chain to this point here. I want to go around that direction. I want to chain it to this point. Then you would first select Auto 2, and in this case, I still use Auto Constant Z, and I simply pick the vertex of where I want to chain to. So that's how that works. One other thing about the vector, just so you know. Let's go back here and replace. When you select an element, let's say I select this over here. Normally I'm selecting here. Let's say I selected here. Notice how the vector is now going the other direction. If you're in standard profile, the tool always wants to, just by default, it always defaults to the left side of the line because that means it's a climb cut as it's cutting. So in this case, it would want to default to the inside. Now, there's many ways to change that. You can simply reverse it right here. You know, it flips it back and forth. Or you could pick the next element in the chain, and it automatically, you know, starts it here and goes that way. Or, you know, you can reverse it by right-clicking as well. So there's a lot of different ways to do it. But the best thing to do is to obviously get used to picking it in the correct location. So the closer you pick to this corner, anywhere from the center point over is automatically going to choose this corner. So you don't have to be right on the corner. Just select close to the corner, anywhere, just anywhere this, you know, south of this side right here of the center point, and it puts in your vector. Now, it really only applies pretty much mostly to just a couple of elements like 3D contour, and it does apply to when you're going into HSS though, when you're picking curves to morph between or something like that. So there are several areas where it applies to. So it's best if you just get used to it, because that way you don't have to keep flipping it or reversing it or something like that. So let's go ahead and let's chain that around. Actually, I wasn't going to use that method. I was just going to use my simple drop-down stock method right there and finish. So that's my profile. If I delete it here, I actually didn't delete it. It's still in my drop-down list. If I don't use it and I use something else, it'll drop it right into my geometries folder where I can use it later if I'd like. Tools, let's talk a little bit about tools. You can either import or you can export from multiple libraries that we've created or that you create. You can also build one on the fly. Let's start off with the library here. Now normally there's a lot more libraries in here, but I've taken some out, and it looks like I haven't repathed my library to the network where I want it. This is just the default location. However, you can put the library structure or path anywhere on your network, so you can all share the files or all contribute to the tool libraries or pull from them. You can have as many libraries as you like. So you can have a master library that has all your tools, or one that just has end mills or center drills or whatever. In this case, I'm going to go ahead and grab a face mill. And by the way, you can import or export in different formats. So if you have another tool library that you can import that happens to be in CSV or XLS, go right ahead. Not a problem. So you can also relate it to a machine, to a particular post if you'd like. So if you always select a given post, it'll always pull up a certain library. Kind of nice. This picture, well, we'll talk about that in a second. Let's go ahead and grab a 2-inch. I just double-clicked, just FYI, and I brought it into my part tool library. 1 second. So in here, you've got your values that are showing. Actually, this is a live representation of what these values are doing right here. So if you make changes to here, it's going to affect this tool picture, which can be turned on and off by here. Another thing about this whole interface, you can drag it. It will remember its shape and size. The reason I say that is because if you choose this button, you can see all the parameters that make up this particular tool in the library. Now, what I like to do, normally there is this description field. Let me pull it over here a little closer. This user-defined tool name and ID number, these two really are generally right here when you load it fresh. What I like to do is just move those out of the way, and you can just drag them by holding on to it, and you see that little arrow right there. It'll tell you where to drop it. I get them out of the way, and here's why I do that, because I like the description field here. As I type in here, it shows me there. And this is a verbatim text field, so you can type in special characters, wingdings, and I'll talk about a couple of wingdings here in a little bit. So that's the first thing I do. I like to get into a good naming convention. Then go ahead and fill out your values. My values are fine for now, so it looks pretty good. I'm just going to go with this and select OK. So we picked our geometry. We picked our tool. We're going to go ahead and pick our levels. What you're going to notice throughout the system is when you select different values, buttons, fields, whatever, you're going to get a picture down here that it describes and shows you exactly what that field is referring to. So starting with your clearance level, which is your rapid plane. That's how far above the part the tool is when it's relocating to different positions on to start work. Safety distances, or plunge clearance, is basically this. If you took 1 inch and minus 50 from it, that would be 950. So it would rapid down 950 and then feed the 50 thousandths down to the material. It just helps you not have a heart attack, rapiding right down to the actual level. You got your upper level and your face depth. You can type in the values, but if there's a button associated with that particular field, I recommend using the button. Here's why. If you pick a vertice, which is the end point of a line, or a face, it's going to highlight the field for you. What does that do? It gives you a deeper level of associativity. It means if this face changes in height, this number will change along with it. But no matter where you pick, let's say we only pick the edge, it's still going to give you the right value. It's just not going to be associated. Not a big deal. And you can use it to your advantage both ways, so keep that in mind. Face depth, we're going to go right down to the face of the part. That'll work. So it's 225. Now, you have a choice here. Right now, step down saying I'm going to take the full 225. Let's say I don't want to do that. I want to do 100 thousandths at a time. Okay, so it's going to take 100, and it's going to be left over with 25 thousandths, and it'll take 25 thousandths for the last pass. That's the way that would work, the way the numbers are set up right now. If you choose equal step downs, notice how the value now changes to max step down versus max step down. The way this works, let me go ahead and turn on my calculator so you can see it. So we're going to take 225 and we're going to divide it by 0.1. Okay, that's if you turn on this checkbox. What does that equal? It equals 2 1/4 steps. Well, we're not going to take 2 1/4 steps. We take 1, 2, 3, 4, 5 whole steps. We don't take fractional steps. So it's 2 1/4. So what do we do with this number? We take and we round that up to 3 instead of 2 1/4. It doesn't matter if it's 2.001. We're still going to round it up to the next whole number. Then redivide that. So if we have 0.225 and we divide it by 3, it's 75,000 steps. So it's not going to change this value, but that is the actual value that it's going to be stepping down if you choose equal step down with this particular setup. So it's going to go down 75, and then it'll go down 75, and so on and so forth, plus 70, and it'll keep going, okay? So clear. At that point, you can do it that way, but you'd have a big step for your finishing at the end. There's a couple other things you can do in here. Let's say you wanted a 10 thousandths or a 15 thousandth step. Well, you could do the math yourself right here. You could turn this off and say, you know what? Let's go down 105. So 105, 2 times would be 210. That leaves 15 thousandths left over. So it'd take 105, another 105, and it would leave 15, and that's what it would take for the finished cut. So you could do the math yourself here if you'd like, or if it's easier, just simply say, I want a 10 or 15 thousandths floor finish, and go ahead and finish. Okay, let me just show you real quick. I'm going to turn that on so you can see it. Okay, so we got our 75 step down, 75, 75, and then whatever's left over for that 15 thousandths. If I don't check mark this, it's going to remove this last line here. There we are. So it's not doing a finish. So when you got done with this, you would have 15 thousandths left on it. But I do want to finish, so we'll go ahead and accept that. Now let's talk about this stuff here. So yeah, you could do it here, you could do it yourself, or you could do it over here. This is kind of nice because then you can tell exactly what you did. But you have a couple different choices. You got hatch, contour, one pass, and spiral. And depending on what you pick, this will change. So if I do contour, it changes to contour and it puts you in there. I'm actually going to do a hatch. You can do a one pass if your tool is big enough to fit across your part. That would be great. But I am going to go ahead and do a hatch. And let's come back here. We'll come back to the hatch in a second. One thing throughout the system that is different than other systems is that this is actually an overlap, not the step over. So if you want to know what the step over is, and right now we're in percentage of tool diameter, you can do it by value. So 0.6 is the actual overlap distance. So what is the step over? The step over value is the I think it was a 2.5 inch cutter minus 0.6, which is 1.9. Or you could do this. You could take and change this to the opposite, 60, and you could look at it. Oh, so it's 1.2. Oh no, sorry. I was supposed to be 70. That wasn't the opposite. My math is not very good. 1.4 is the actual step over. So it must have been a 2-inch. Yeah, it's a 2-inch tool. Okay. So 1.4 would actually be the step over. I don't want this to be confusing. The only time you're going to see a small value in here that's not at least 50% is probably in face mill, because we take a greater step over for face mill. So right now, this is a 30% overlap, not a step over, overlap. Okay, hope that makes sense. This is the only thing that's not real self-explanatory, but the best way to say it is just, if you really want to know what it is, put in the opposite, and you can take a look at the value. So that's your actual step over. Okay. All right. Equal steps, same thing as this whole max step down. We do that subdivision to make sure, if you look at the picture here, ready? Okay, it makes sure it puts in an equal step over value. Zigzag in one way, this is to cut down on your rapids. So if you want to cut down on your rapids, do a zigzag. So it'll go across the part and it'll go down over here and then come back. But if you always want to start in the same point at the same place, well, it's going to do a rapid back there. So I'm going to do a zigzag. You can reverse the toolpath. Maybe you don't want it starting here. You want it starting at where it ended. So that would be over there, reverse toolpath. Constant Z level, we'll talk about this when we get to pocketing, because it's easier to explain. This picture's good in that it shows you what it's for face milling, but you're going to see complete Z level throughout the system, and this is the only place that it's slightly different or appears different, because it's actually exactly the same, but it appears different in facing. This is like regionalizing the cutter, but I would say that it's more of a thin wall feature, and I'll explain that when we get into pocketing. All right, hatch. Since we are doing a hatch, you can define any angle you want. By default, we're going to go along the X direction. That's 0. Okay, if you want it to go 90, go ahead and type in 90 there. That would follow the Y, or any increment thereof. Extensions and across, we already, as you can see, already come off the part. So the tool is already off the edge, but we're going to go, right now it's 10% over the edge of the part. So, and on the sides, we're at 25% of the tool diameter off the side. So if you want more, you can put it in there, but by default, we come all the way off the part. We start off the part and we come all the way off the part. You have one way and zigzag here, which is a little bit different than the one that's on this page. This is for depth cutting. As you can see, it says depth cutting right there. And this is for cutting direction. So this is very handy if you're using an older machine, and they always, they just seem to cut better going from negative to positive or positive to negative. Sometimes older machines cut better in one direction. So this would be the way to make sure that that happens. I'm on a newer machine, so we'll just do zigzag. And one other big thing that I really, really like is the corners. As you can see, these are an abrupt stop and then a move and another abrupt stop. Well, I prefer high-speed toolpath, which is nothing more than tangent continuous. So if I turn on fillet, it'll automatically put in the arc size that it needs based on the step over, based on my tool size, all that stuff. All you have to do is turn it on. That's a much smoother transition. Advanced, these are just like the drill cycles, or the drill patterns, I should say. Maybe you want to face this direction. That's fine. You can do that, or however, whatever pattern that you'd like, you can go ahead and do. They are the same patterns as drilling, though. Just FYI. That's it. Go ahead and save and calculate. Make sure that's already calculated. And we're not going to worry about verifying it right now. Let's go ahead and jump into we need to rough. So we could do it with a profile, or we could do it actually with a pocket. Now, what's cool about pocketing is you can turn it into a profile operation, and that's what we're going to do. Because profiling, well, we have a lot of material to take from here to here, and that's totally different than the material we need to take from here to here. But if we did a profile, that's going to do nothing more than offset the profile. So we'd be wasting time cutting, well, pretty much on all other three sides when we have this much material to remove. So what I'm going to use a pocket, and I'll show you some really cool, this is more of an advanced feature, but it's very handy. You can take pocket. Again, we're just going to work our way down. There's that selection method you're used to seeing. The first thing I'm going to do is I'm going to chain, because we're in 2-axis, I'm going to chain my edge, and I'm going to chain it all the way around. Now, right now, that's a hard boundary. That means the tool has to stay inside here, and it cannot breach that wall. But I want it to. I want it to start out here and work its way in. So what I'm going to do is simply right-click on it and mark the chain as open. Not a certain edge or certain edges, but the whole chain as open. Okay. Now that I have that boundary of my stock, I want to chain my actual part. So I'm going to go ahead and click down here and auto constant Z as well. And now that's a hard boundary. I have a soft boundary here and a hard boundary here. So now it knows, well, where the material is, where the part is, and that the tool is allowed to start outside here. Okay, so we'll go ahead and hit finish on that. You might want to give it a name. If you don't give it a name, it'll be contour, contour 1, 2, 3, 4, so on and so forth. You can always see the list of names in here, but you can also show in case you forget to name them. Tools, let's go ahead and create a tool now instead of grabbing one from a library. So I'm going to go ahead and create a new tool, and I'm going to do an end mill. And I'm always going to start off my description. I'm using this is a verbatim text field, so you can type in special characters, wingdings, whatever you like. By the way, that particular symbol is created by using the Alt key and the number pad, not the numbers across the QWERTY keyboard, across the top. Has to be the number pad. Hold down the Alt key, type in 0216. And if you're looking for the degree symbol, that is the Alt key and 248. So I'm going to put in a half inch 4 flute end mill. This description is going to be output in the G code along with up to 5 more messages for that one tool. This is again the live representation of what these numbers are doing. So let's match them up. I'm going to have a half-inch tool. I'm hanging out of the holder, which it says right here. Here's a 3-inch long tool, and I'm hanging out of the holder 2.5 inches. But I'm not showing a holder, and you don't have to include a holder if you don't want to. But if you do, we do have some basic ones in here that you can pick from. If you include a holder, we will a gouge check against it for you. And if these aren't the type of holders or sizes or shapes or whatever that you use, not a problem. Simply draw the profile inside Inventor, and we'll revolve it around into a solid shape for you. Same with the custom tool. So you can have a custom holder and you can have a custom shape tool. So now you can see clearly we are hanging out of the holder. Now kind of far. I don't think I need to go that far. So I'm going to do 175, and let's make this 1.5. Generally, generic end mills are always, the flute length is always 3 times the diameter. So, and then 4 flutes to match my description up here. All right, tool data. Because we're not in iMachining, you are going to have to pick your own feeds and speeds. But there's a couple ways you can do that. You have feet per minute, RPM. They are dynamically linked to each other. If you're used to doing feet per minute, you can do that. So let's say this is 600 feet per minute. You know what the tool can do. What is that in RPM? It's a little over 4,500. Same thing happens. Let's see, do I want to do that? Yeah, that's fine. 4,500 is fine. Inch per tooth and inch per minute, they are also dynamically linked. So let's say 2 thousandths is what? It's 36 inches a minute. Well, let's do that. Sounds good to me. If you need to turn on a finish for your or speeds and feeds, different feeds and speeds for your finish, you can turn on finish feed and finish spin, and you can change those values if this tool is going to do both roughing and finishing. So it will automatically use those values once it goes into its finish cut. All right. Coolant. Only the options that is available on your machine should be shown in green with the green check mark. If they are not, just get with us and we'll make sure that your post reflects what your machine can do. I'm going to go ahead and turn on Coolant and go ahead and select that tool. Moving down to levels, let's go ahead and pick right off the part. We've talked about these values here, so let's do this. We're doing the outside cut, so I'm going to go ahead and, actually we've done a face, so I'll pick off of this face, and we're going to go down to the bottom of the part. And actually, I think we're going to go a little bit further because I want to come down a little bit further. So I'm just going to put a little -20 thousandths to drive the tool a little bit deeper. And I do want some step down, so let's do 5/16. All right, technology. Again, you've got hatch, contour, hatch plus finishing, or even plunge patterning, plunge roughing, if you will. I'm going to use a contour. Here's my step over. Normally, I'm about 65. I don't like 50 simply because if you have a greater step over than 50, or even sometimes 50, especially with a tip, like a bull nose or a tip radius, you can leave a stand at the bottom. So I prefer to have a bigger step over. Rest material and chamfering, won't talk about it right now, but you can take this pocket operation and you can turn it into a rest or a chamfering operation. Here's that complete Z level. Now you can see it's a little better of a picture to show you that if you're off, you're going to go 1, 2, 3. So you're going to stay on this side, and then you're going to come over here. That cuts down on rapids, but it's not very good for a thin wall feature. If you turn it on, then you cut a little bit on this side, a little bit on this side, back and forth until you whittle that wall down. That's the best way to cut a thin wall feature. In this case, we don't have any thin wall, so I'm going to turn that off. I'm going to go ahead and leave 10 thousandths on the wall, as well as the islands. Even though I don't technically have an island, I've just experienced where I was cutting a pocket and it came up close to one of my walls that wasn't an island, and I realized when I put the value in here, it fixed it. So I've gotten used to putting in 10 thousandths here. Now, that's since been fixed. That's just a habit I've gotten into. We're going to go ahead and finish the floor as well, so I'm going to put 10 thousandths there as well. So we want to finish the wall and the floor. Let's see here, offset, no. We want to finish each depth at the total depth. Otherwise, if we did each step, it would take a finish cut at each one of these steps. We don't want that. We want a total depth. You could turn this into a wall finish only if you wanted to, but we don't want to. And of course, I want to turn on cutter comp because that'll output the G41, G42 for your machine. So if you want to rerun this operation without coming back in here and adjusting values or anything, you can just simply adjust the wear factor on the tool and rerun it, and then get a little closer or a little further away, however you want to do it. That's pretty much it. We don't need to talk about links right now, so we're going to go ahead and save and calculate that, and we're going to turn it on. Now you see that this is a pocket style operation. It didn't waste all these moves way out here, okay, because we changed the boundary. But it is still a pocket operation, so it wants to start here and pocket out. So it's going to ramp in or start outside and come all the way in here and then work its way out. Yeah, that could work for you, but there's a better way to doing that. I'd prefer the tool to totally start on the outside. Now remember, we marked one chain as open, and since we did that, this becomes available for us to use. Even though it's a pocket operation, open pocket basically turns it into a profile style cut. So what we're going to do is we're going to turn on profile cutting. We're going to approach from the outside, and we're going to descend in rapid to the cut level. Because we're in air, we can rapid down to the cut level. And now look what it does to the toolpath. Let's try to get this up straight here. Ready? Save and calculate. Now you actually have actual profile cuts everywhere, but without wasting time to cut air. Let's go ahead and take a look at that. Now our face mill has already been done. I'm going to use Solid Verify. Our face mill has already been done, so that's already been taken off. So we won't see that. We're just going to watch the pocket. If you want to watch the face mill, then you're going to want to select face mill, or because if you only do that, that will only play the face mill and it will not play the pocket. So if you want to play them all in consecutive order, just select the operations up here or select the one that you want. So we'll do operations here. By the way, selecting anything else at any point, so even though we're in the middle, if I select it, it automatically resets. Okay, all done. Sounds good. Actually, you know what? I just realized we're not cutting the floor. Let's go back to technology. We're cutting down below. We're not finishing the floor, so I'm not going to worry about finishing the floor. So I'm going to take that off. That was a waste of time. All right. We have some steps to rough off of here, and it's going to have to be done with the bull nose, or you have to do it in end mill and come up to this edge, and then a ball nose. That seems like a big pain. So we'll do it with the bull nose. But we have 2 steps and a pocket to take care of. So let's go ahead and do another pocket operation. Now what I could do is I could just copy this and then change out the tool and the geometries, but there's pretty much everything I have to change on it. If there was only a couple things I had to change, doing a save and copy down here would be probably the best. Well, I'll just do it anyway so you can see it. So I'm going to save and copy it. It's going to close that operation, open up a brand new one, and then ask me to pick new geometry. So I'm going to say new. And we're going to start off with that edge. All right. So that's what I want to cut. But I want to mark some of these open edges here out front as open. So we're not going to mark the whole chain like we did last time. We're going to mark just some of the edges as open. So you can toggle them between an open or a wall, or just toggle them back and forth. From 2 entities, just so you know, if you were to do like, let's say when you chained this, you didn't have an edge to pick, but you had to go from point to point. Well, if you went from point to point, then you're going to have to use from entities and select those 2 points, like this point to this point. Oops, let's go this point to this point across the top of this. If that's the line you picked, there's no actual edge here. So in order to open that edge up, you have to from 2 entities, and you have to pick the same order, from and to. So just an FYI. So the open edges that we want to pick are right here. So I'm going to put my cursor over there, right-click, select other, and yes, I want to use that edge. It's actually pretty easy. Right-click, left-click, left-click. Right-click, left-click, left-click. So it actually goes pretty fast. All right, one more to do right here. And now we have a hard boundary, which is the magenta, and that tan-colored yellow, I don't know exactly what color that is, but that's the open edge. So we'll go ahead and finish. And let's call it step. Let's give it a name. Finish. Tool. Now we did a save and copy, so it's using the old end mill, but we actually need a bull nose, so we're going to create a new one. Again, verbatim text filled. We'll do a 1/2 inch for flute, bull nose, bull nose with a 125 tip radius, because I know that's what my corner is. Or otherwise, you could use tools or inspect to find out what the corner is. All right, it's a 1/2 inch, so we'll put in a 1/2 inch here. It's 125. You can see that it's starting to take shape here. Let's pull it up here. Let's do one. Let's do the same size here. 1.5, 1.5, and 4. All right. I'm not going to worry about my feeds and speeds or colon or anything. We understand that now. Levels. We're going to go ahead and pick off the part again. Notice this is all the information that came from this. So this is why you have to decide whether it's easier or if there's less to change if I save and copy versus just starting a new one. Face operation should still be in the same place. So for the face operation we did, it came down to this. So this should still be selected correctly. If you want to double check that, you can. It is right there though. Pocket depth, we're going to come down to this face. So we have a total of, looks like 1 inch. Because this value reflects what the difference is between the 2 points that you selected. and it's saying 1 inch, and we're going to go down at 3 1/4 or 5/16 again. So let's go ahead and go to technology. This time we definitely want to do a floor finish or a floor offset and a floor finish. So everything else looks like it should be fine. So let's go ahead and save and calculate and turn on the toolpath so you can see it. Now it automatically did that profile because remember we copied the other one and it was already turned on. Here's what it would look like if it wasn't turned on. More of a pocket style. Save and calculate. Let's take it into simulation. Now just FYI, see how this came in all faceted like that? That has to do with your accuracy in here. Let's change this to 5,000 or half a thousandths. Yeah, just either exit this or just pick on something else and come back to it, and it should be a lot smoother, as you can see. Let's try that again. Now, if you change that, it only affects the display, not your G-code, but it can slow your system down, so make sure that you're not, cranking it too low. Looks like it's doing pretty good. I think we have one more cut. Then it'll do a finish on the floor first and then come up next to the wall, which is what I would prefer to do. Or did it do the finish on the wall first? Let's see here. Over the wall and then finish. There we go. All right. Now that looks pretty good. We do have another step over here though, and we can either save and copy and pick new geometry, or we can just add it to our existing geometry. So if we go back to geometry, and instead of selecting new, we're just going to select edit. So we see our old chain in there. Let's just put in a new chain. We'll start here. Yeah. And we'll work our way down around the front here. Oops. All right, and then we're going to mark that some of those edges is open as well. So we'll mark this one. And this one. All right, got all of our open edges. So all we have to do is finish this and save and calculate. And now we have toolpath on that side as well. Simulate, play. Let's crank it up. Very nice. All right. Now we do have a pocket here to do, and actually what I've been realizing is that I forgot to put my radiuses in there, but that's fine. We can just form those with the tool. So even though we did an open pocket on these two edges, these two other profiles, we don't have to open up the profile on this. We can add it to our geometry and simply select our edges and chain it around. And we won't mark that as open for anything. And we'll save and calculate. Now we have toolpath in the middle. However, you notice that it's plunging straight down because that's what it's doing off the sides of the tool. We actually want a helix, but we want a helix just for this pocket, not for the rest of them. It'll automatically figure out where it's at and know where the material is, because especially since we use 3D model for our stock. So I'm going to come down to my links, and I'm going to turn on helical. And you can change the data size and everything, how big the chain is. It's checking everything, change the angle, change the size of the radius, maybe only want 200. That's fine. Select OK, save and calculate, and now you have a helix just into the pocket area. It's not going to waste time helixing out into the air. So let's go ahead and save and play that one. So once it gets down here, it's going to come back and do all the finishing. So it's roughing right now. There's finish the floor and wall, and finish the floor and the wall in here. Excuse me. All right. Let's see. Got to drill some holes. We got to flip this over and face it off and then drill some holes. So Let's do that. But in order to do that, if we're going to take this out of the vise and flip it up here, we need another coordinate system with the z-axis or spindle axis perpendicular to the bottom face now. So what I'm going to do is come into coordinate systems, and we're going to add one more. And I'm going to pick this face. And I don't know why it spun over there. Let's pick the origin off here and rotate it around Z to get our X going this way. So it sits in the vise like that. Okay? All right. Now what we can do is actually copy this face. We're just going to copy it and paste it. Now it's the old, that's that face. So if we generate it, it would be exactly the same as this one right here. But we actually want to cut it from a different coordinate system. So I'm going to pick Mac 2 position 1, and there are no profiles or geometries associated with that Mac position. So we're going to create one. And we can do the same thing we did with the first face. So finish, and now we're going to save and calculate, but it's going to tell us that the floor offset is greater. That's because we picked all of our values from the other side. Not a problem. Upper level is here, and face depth is right here. Select face. Now we should be able to generate tool path, complete with all of our floor offsets, our step overs, and all of our step downs as well. And you're going to notice that it put it inside Mac 1 or Mac 2 position 1, and there's our face. All right, now let's go ahead and drill a hole. I mean, if we went ahead and, well, let's go ahead and simulate it so you can see it. So that's basically what we're looking at, what we're working with. So let's go ahead and drill some holes. Drilling. Again, same dialog box. We're in the right coordinate system, so we need to select holes. It's looking for holes. So you can come around here and pick these individually, right-click and select, and you can select them individually. Or you could pick the face, and it'll select all the holes. Whoops, I meant to do, really? Oh, that's interesting. How come it won't let me pick the face now? Here, let's see. Right-click. Oh, there we go. Select other. So if I select the face, it'll automatically select all the holes on that face. And then, of course, you don't want to do this one. Maybe you want to drill these smaller holes. You can find that one, which is this one, and simply right-click it and delete it. You can also move these around. Drag and drop them. That would be simple reordering. Let's do it there. We have more complex ways or advanced ways of changing the order of your drilling as well. You can also bias these. Let's delete those. And let's say we want to bias it by that radius size. So we want to pick all the holes on this face that are of that size. Well, then you'd come down to by radius, either type in that value or hit the button, select your hole. It automatically puts in that value. Then you can pick the face, and it will only pick the holes of that size on that face. Now, if this wasn't a face and it was a more domed shape, and it was not an actual circle, it's more of a nerve spline, well, then you could use 3 points on the circumference to pick that. And you could pick just 3 points, any 3 points that you pick on that circle, and it'll automatically find the center of the hole. All right, looks good. Let's go ahead and use those. Tool, we're going to grab a tool, and we're going to use a drill. Now, I didn't even remember what that value was. I think it was 245, but I don't remember. So if you don't remember what the hole is, or if you need to pick it, you can just put your cursor right inside the diameter field, make sure it's blinking in there, as you can see, and then just simply come out here and select that edge. Oops, select edge. It automatically puts in that diameter for you. So for, oops, 0.409, drill. All right, maybe it's a self-centering drill, so we'll use that, and we'll just make it look more like a drill there. There we go. Yeah, give it a holder if you want. Levels. Well, we're going to be cutting from this face. Oh, that's interesting. How come sometimes that does that? There we are. Select face, which is the face of my part. And we're going to drill depth down to this face right here. That looks good. The only problem with that is that right now we're in cutter tip, so the cutter tip would come down to the bottom of that face. Well, that's not going to push the tool all the way through. So you're going to want to use full diameter, which takes this edge to the bottom of that face, and still it's not quite through, so I'm just going to give it a little push through. Now, if we're doing chamfering, we would use our diameter value, and if we have time, we'll get into that today. So I think we will. Technology, here's your different routes. You can take the shortest route. You can use advanced options. How do you want to drill? These are just your patterns. You can reverse the direction. I'm just going to do default. And what kind of a cycle type do I want? G81 is just going to be a straight drill through there. Since it's so shallow, that's what I'm going to use. But you can use a G82, which has a dwell, or a G83 where you can do pecking, come up to the rapid plane or the clearance plane, or just break the chip. You can have dwells. You can have variable pecks. That's all inside here. And by the way, if you pick it, it'll show down here in your data. So you can put in the values you want. In a pecking environment, I'd probably do this. Say 100 thousandths. No, I don't want to come all the way out of the hole. And yes, I want to break the chip. So just back up 10 thousandths, break the chip, and then go down another 100. Here's your dwell. If you're doing variable pecks, you could fill out this information. But I'm not going to do that. I'm going to do a G81. And notice how there's nothing to pick in there. G81 is simple. If you pick a G82, you have a dwell. So you can put in a 1 second dwell. That'd be a 1 second dwell. But we are doing G81. So save and calculate. And there's our drilling. Let's go ahead and take a look at that in Solid Verify. And play. Pretty straightforward. All right, chamfering. Since we do have some time, I definitely want to do that. I want to chamfer those holes. And since I've already selected those holes, I'm actually just going to double-click into my drilling operation and do a save and copy. So it's already got my values, or my center drills picked, or my center of my holes picked. So I need to change a tool because I'm going to do some chamfering. I just got to make sure that my chamfer tool is going to be big enough, and actually I didn't put any, I didn't physically draw the chamfers in here. Oh, darn, I should have. Okay, well, I'll show you how this works anyway, regardless of whether you have a chamfer on there or not. That hole is photo 9. I think it's like a 1/2 inch chamfer that normally I put on there. So you got to make sure that your spot drill, your spot drill is at least a 1/2 inch or whatever the outside diameter of that chamfer is. So in this case, I'm just going to do 625. So 625. So I'll call spot drill. All right, and of course the angle matters because we're not going to be picking depths. It's all based on the chamfer diameter that you want and your angle of your tool. So make sure that your angle of tool, if it's an 82 degrees chamfer, then you're going to want to make sure that's put in there. Mine's 45 degrees, so let's go ahead and select this tool. Now, when it comes to chamfering, everything needs to be set at 0. So I'm going to set my upper level at the same place as I set my pocket depth. And you'll notice this will turn to 0. Watch. All right, so I picked both faces at the same place or same level, and this says 0. You want this to be 0. Now, you didn't have to pick that. You could have just simply typed in the 0, but then it wouldn't be associated. All right, this is where you would select diameter value and either type in the value of the chamfer, of the top of the chamfer, the size that you want, and then the drill will figure out how deep to go in order to make that happen. If you don't know the size, again, you could simply pick right off of the value. Now, that's the hole size. So let's just do a 1/2 inch. And let's take that into verification. Now we'll slow it down. Bink, bink, bink. And actually, I have a feeling that's probably a lot bigger. I'm going to go a little bit more. Let's try 550. Yeah, that's good. We'll go with 550. All right. So that's how you do a chamfering operation. 2 weeks from now, we're going to get into cutting these angles here. We do have another hole to put in here. You know, I think I do have a little bit of time for that, but you know, I stopped that for the SolidCAM guys too as well. So I think I'm going to stop here for today. We'll put in the hole next time, and then we'll start another part. Well, actually, we'll finish this up, but we'll start another part after that. So if there's any questions, which I don't see anybody's hand raised, and I don't see any questions yet, but I'll leave this open for a couple more minutes to see if we have any questions. If you would like the recording of this video, just send me an email. Again, my email, you should be able to see it in the bottom of your GoToMeeting webinar dashboard. It's darren.bryan@solidcam.com. If you want this video or any others, just send me an email and I will get that out to you. If you have suggestions on different webinars that you'd like to see, something that would go deeper into some particular area, I would love to know that, because I could do a webinar on, say, 1 or 2 or 3 different areas. I think that's it. So in 2 weeks, we'll continue where we left off. Looks like we have a question. How did I change the resolution? Right up here above Inside Solid Verify, above your 2 rows of icons, is Settings. Now, generally, if you've never been in here, this is what I recommend doing. Come into General, make sure you hit Defaults to set your values here, as well as your frames per second versus by fixed step. This is default. In the old versions, it was always by a fixed step, and it was set to 15. This means that it would show every 15th tool move, which is very jerky. I like to set it to 1. Okay, this is not the resolution, but I'm getting to that right now. So you want to do that first. Now your resolution, your tool settings for faceting tolerance, and remember, the faceting tolerance is only for display purposes. It has nothing to do with G-code, okay? Sorry, I've got a bug in my throat here. Accuracy is where you want to go for the resolution or the faceting tool tolerance. By default, it's set to 4 thousandths, but you can change that to whatever you want. Now, if you have a fast computer, like this particular one, my new computer is very fast. I have a solid-state hard drives. It's an i7. It's got 16 gigs of RAM. I mean, the thing is really a workhorse now. The old one wasn't so much. If it's a small part, like 6 inches or smaller, you can get down into the tenths with the standard computer. But I'm even doing pretty large parts at even 2 and 3/10 sometimes. Now, the other thing about this, again, it doesn't affect your G-code. It affects how nice your part looks in here and how fast your computer runs. However, it does affect one other area, and that is your compare function. If you're set down to a 5 thousandths facet tolerance, that's as low as you should even ever need to set these, because it won't do any values lower than a 0.5 thousandths. I mean, you could type them in there. I could type them in there, but it's still going to see that it's a 5. It'll only go down to with whatever you have within your accuracy tolerance. So, just an FYI. Let's see what that looks like, as a matter of fact. Yeah, it looks pretty good. All right. So that's where you set your resolution. Now, there are some other resolutions, or facet tolerances, I should say. Initially, when you create stock and target, again, they don't affect your G-code, just how nice your parts and your tool path and stuff like that look on the screen. Nothing to do with G-code. So you have a facet tolerance for your stock, and you have a facet tolerance for your target or your part. So here, I'll just show you. Let's say I set it at 10, and I'm going to show my part. It's kind of hard. Yeah, see how faceted it looks here. Let me blow this up. Look how bad that looks, okay? So pretty bad. But change down your tolerance. And tolerance, or the opacity, it's much better. All right. Any other questions? Give it a little time. And remember, if you forget to ask a question now, send me an email. I'd be more than happy to answer. My cell phone number, tech support numbers, email address, all that information is in my email. Again, darren.bryan@solidcam.com. All right. Next week is going to be on SolidCAM, and that's going to be part 2 of SolidCAM Basics. And InventorCAM Basics part 2 will be 2 weeks from now. So not next Tuesday, but the 2 Tuesdays from now. All right, I think that's it. I'm going to go ahead and kill it today. Stop the recording, and if you guys would like that, just send me an email. Thank you for joining me, and I hope to see you guys next time.